Hello, we are discussing about GATE 2014 ECE paper. The equivalent resistance in the infinite ladder network shown in the figure is RE. This is equivalent resistance RE, and find the value of RE by R. What is the value of RE by R? That we are going to calculate. Okay, so if you are observing, this is infinite ladder except for the first branch, which is 2R, and all other branches are going to be having R value. Okay, so if I am going to look at this point, okay, now you are going to be looking from this point, that is if you break the network, and you are going to be looking into these two terminals. Can I say that one? Now it is going to be consisting of identical resistance and identical configuration, same R plus R, that is two resistors are going to be connected infinitely. So 1R, 2R, this combination is going to be connected infinitely, and assume that, okay, the equivalent resistance looking into this network between these two nodes, okay, so that I am assuming it as Rx. Rx is going to be the equivalent resistance looking into infinite ladder, which is starting from 1 and 2 nodes, for example. Then RE can be written as like this. This is 2R and R is also present, and after that one equivalent resistance is nothing but Rx. So now the circuit can be written in this way. This is RE and it is 2R, this is R and it is Rx. Okay, now the circuit is replaced in this way. Now from this one you can write RE is equal to R parallel Rx plus 2R. R parallel Rx plus 2R. So if you calculated Rx, then you can calculate the RE in terms of R and get the ratio of RE by R. That is the required answer. Okay, so now we are interested in calculating Rx. Okay, so if you are going in this way, if you are looking into this point, at that time the equivalent resistance between 1 and 2 are going to be Rx, as two resistances, that is R and R, are going to be connected infinitely. Let us assume you are going with these two nodes. This is something as 3, 2 nodes. If you are looking into these two nodes, at that time also, if you are looking into these two nodes, okay, say it as 3 and it is 2 because same node. So if you are looking into these two nodes, then it is going to be looks like same as previous. Whenever you are looking into 1 and 2, at that time there are number of R and R branches are present, that is combination of R plus R, that is present. Here also you are going with the same thing, two resistances are connected, okay, infinitely. Here also you don't know the infinite number, just simply you are subtracting one branch from the infinity, that is equal to infinite only. So equivalent resistance here also you will get it as same as Rx, because we cannot define the infinite. And here 3 and 2 terminals are going to be indicating infinite minus 1 branch, that is equal to infinite only. So you will get the same equivalent resistance. Then we can draw, okay, that 1 and 2 terminals can be written like this. In between 1 and 2 there is a resistor, and one more resistor is there, that is R and R, and these are the 3 and 2 terminals. Between 3 and 2 terminals the equivalent resistance is Rx. So the resistance looking into this 1 and 2 terminals is also Rx, resistance looking into 2 and 3 terminals is also Rx. So that Rx can be written as Rx is equal to, okay, R plus R in parallel with Rx. Rx can be written as R plus R in parallel with Rx. Okay, now I am going to simplify this expression and getting the value for the Rx. Okay, how I am going to simplify this one? Rx is equal to, okay, R plus R into Rx divided by R plus Rx. Okay, so this will be R square plus R into Rx plus R into Rx divided by R plus Rx is equal to Rx. So you can simplify this one. It is Rx plus 2 times of R into Rx, which is equal to Rx into R plus Rx square. So now you can write it as Rx square. Okay, this is 1 Rxr, whereas it is 2 Rxr. If this 2 Rxr coming this side, at that time it will become minus 2 plus 1. So minus R into Rx. This is 2 times of Rx. If it is coming over this side, that is minus 2 times of Rxr. And this is plus 1 of Rxr. You will get it as minus Rxr. Okay, Rx into R. Next, this R square, it will become minus R square is equal to 0. Now, think it is, this is in terms of ax square plus bx plus c equation form, where a is equal to 1, okay, x is nothing but Rx. So, x is equal to Rx in our case. So, a is equal to 1 and b is equal to minus R and c is equal to minus R square. So, you can write the roots for this one, minus b plus or minus, okay, x is equal to minus b plus or minus b square minus 4ac divided by 2a. So, use that equation, okay, use that equation to get the value of Rx. Rx is equal to minus b, minus of minus r, that is nothing but plus r, plus square root of b square, that is minus r whole square is r square, plus 4 a means 1, c is minus r square. So minus into minus plus 4r square it will become 4r square. So r plus r minus divided by 2a, that is 2 itself. So Rx is equal to r plus or minus under root of, okay, 5r square. R square plus 4r square is 5r square. So that you can write as root 5 into r divided by 2. Root 5 is 2 point something, so that it will be larger. If you are choosing minus sign, Rx will be negative. So Rx cannot be negative. You must choose positive sign only. So Rx is equal to, you can write it as r plus root 5 times of r divided by 2. Okay, so 1 plus root 5 by 2 into r. So 1 plus root 5 by 2 into r, that will be equal to 1.62 times of r. Rx value is 1.62 r. Now we have calculated Rx in terms of r. Now we will calculate Re. Re is equal to r parallel Rx, that is 1.62 times of r plus 2r. Okay, so Re is equal to finally this is r in parallel with 1.62, it will be equal to 0.618 r, 0.618 r plus 2r. So Re value is equal to, Re value is 2.618 r. Re is equal to, so Re by r, the required ratio is 2.618. So the ratio required is 2.618 or it is 2.62 approximately. So the right answer for this question is Re by r is equal to 2.62.